Ever since I made this combination sander about a year ago, I've wondered how I managed to make anything without it. But it does have a few limitations. It can't sand inside corners, like on this piece, and it can't sand inside curves, like on this piece. The typical complement to one of these sanders is usually a 1-inch strip sander or an oscillating spindle sander. However, a typical 3-wheeled strip sander can't sand an inside circle like on this piece. And on the other hand, a spindle sander couldn't sand an inside corner like on this piece. So I had the idea to combine the two sanders and make a spindle sander and a strip sander in one machine. I designed this vertical strip sander with removable platens that allow me to sand both straight lines and inside corners, as well as inside curves and inside circles. It's simpler to make than a traditional 3-wheeled strip sander, and it's certainly easier to make than an oscillating spindle sander would be. With the flat platen, it can easily sand inside corners and straight lines, as well as round over edges like a traditional disc sander. Swap out the platen for the curved one, and it can sand inside curves. With the vertical 2-wheel design, it can also sand inside circles, so having the correct hole saw is no longer needed, as I can get the perfect fit using this sander. With a slow-running motor and a dust collection hose hooked up, there's practically no dust even after all of this sanding. Let me show you how I made it. I'm going to start with the hardest part, which is making the wheels. There are 2 wheels, one for the drive and one for the idler on the top. So let's start with the drive wheel, and to start I've got my blank here of piece of plywood that's cut to 1 inch thick, and we'll go rough out the circle on the disc sander, and then we'll put it up on the motor and spin it true using the motor. I've got the motor clamped to the workbench, and then just a few pieces of scrap wood clamped next to the motor as well, and that'll act as a tool rest that I can use just a chisel and go ahead and true up this wheel and also add a crown to it. Now it's nice and round, and you can see the small crown that I also put in it. This face and this face are a little wobbly, but they don't really matter. They don't really interface with anything. So all that matters is that this is nice and round and there's a little bit of a crown. All we have to do to finish the drive wheel is add this little piece of rubber, which came from a bicycle inner tube. And this will just give the wheel a little bit more traction, and it'll grip nicely on the sanding belt and it won't slip. The idler wheel is also a 1-inch piece of plywood cut to the circle with a hole in it. The idler wheel gets 2 ball bearings, and I'm essentially using these roller skate wheel bearings, and these are always metric. So they're about 22 millimeters on the outside, and the closest thing I have is a 3/4 inch bit, which is about 1/2 mil too big. So that means these bearings pretty much just fall right through here, and that's not good. So I found this little piece of plastic, which is actually a label holder for envelopes or folders. And I found that cutting out just a sliver of this and wrapping it around the bearing is just the perfect amount of shim to tighten up and make a really nice fit between the bearing and the inside hole that I drilled here. Before I push the other bearing into the other side, to keep the space between the two bearings correct, I'm going to drop in a washer and then a nut and then another washer, and that'll set the distance between the two bearings. And then I can go ahead and press this ball bearing in. First, scooting down that little shim so it can get started in the wood, and then I'll press it in. To act as a shaft or axle, I'm using this 8mm threaded rod, which used to be a bolt. I just cut the head off of it. And I'm going to thread it through the nut that I inserted in between these two bearings, and I'll center it. Two more washers and two more nuts, and we'll be ready for the next steps. In order to turn this wheel true and also add the crown, I made this little jig just out of some scrap wood. And the important thing to see here is that this is at a slight angle to this board. And so when I put it up here on the disc sander, I'm going to use this as a guide, push it up against the disc sander as it's spinning. And since this is at a bit of an angle, I'll be able to make this wheel nice and round and also put half of the crown in. And then once I have that half of the crown in, I'll take the wheel off, spin it around, put it back on, and then I'll make the other half of the crown. All right, got a nice round idler wheel with a small crown to it. Now the real question is, does it work? So we should test it out real quick. I got a sanding belt. I'll just loop it on the motor. Success! So it stays on, and I can adjust the tracking by pivoting the top wheel here, and that is due to the crown. Looks good. To hold the idler wheel up top, I'm going to use this piece of hardwood as the main support. So I need a way to attach the idler wheel to this main pillar, and so I'm going to use a couple pieces of aluminum to make some mounting plates for the idler wheel. I cut this piece of hardwood to act as a spacer between these two end plates, and that allows this to slide in just nicely. So I think I've changed my mind about using the piece of maple to run the whole way down as the support, and I'm going to use a piece of aluminum, and you'll see why later. So in order to fasten this to the top, I'm going to put a small groove the depth of the piece of aluminum and also the width so it can sit down inside of here. To hold these three pieces together, I'm going to use a machine screw, and to get the holes lined up on all three parts, I'm first going to tape them all together and then drill them all at once. but I learned by doing this that drilling through both aluminum and wood at the same time does not work very well at all. The aluminum chips kind of get stuck in the wood, and the tape I was using wasn't good enough to hold these pieces together while going between the aluminum and the wood. So I ended up going back and re-drilling these separately after I kind of marked the hole with a drill bit first. Instead of using nuts for the machine screw, I'm just going to tap the piece of aluminum. So one side gets the tapped holes, the other piece of aluminum gets a through hole with a counter bore to sink the head down in, and then the wood piece also gets the holes enlarged so that machine screws will fit through. I want to make the adjustment mechanism for this sander the same as I made for my previous sander, where I have a threaded bolt going through the drive or the idler shaft, and turning that bolt allows me to adjust this shaft in and out on this slot, and that works really well. So that means I need to drill a hole and tap it on both sides through these nuts. I cut the bolt off both ends, and that makes this assembly pretty much done. To fasten this to the main support, I drilled a hole through the block here and also tapped a 1/4-inch hole in the aluminum. And then since this locks in the front, all I have to do is use one bolt from the back, and that'll lock this upper idler assembly to the main shaft. Now that I have the idler assembly done, I can move on to the rest of the sander. So I've already cut out a few pieces on the table saw out of 1/2-inch plywood. I've got this base, which the motor will mount to. Another piece here, which is going to separate the motor from the main dust housing, which is these pieces also. And I've got a hole cut out here for a dust collection hose. And then a front piece here. And this will start to form the main box where the sanding belt's going to spin in. To attach the idler wheel and the main pillar to the rest of the machine, I've got another piece of hardwood here, and I'm going to attach that to the back of the aluminum bar, and that'll get screwed to the main body here, and will make sure I line up the idler wheel right on top of the wheel that's on the motor. That way the tracking of the belt works out. With this just lightly clamped in here for now, I can rotate this whole piece and slide it front to back this way, and also slide this whole box in and out. And I'll do that while the belt is running, and I can find a sweet spot for where all the alignment lines up and where the belt runs nice and straight. With this pushed all the way up against the motor, the belt is running nice and straight on the two wheels, and there's a pretty even gap between the belt and the aluminum platen, so I think the position is close enough. I plan on attaching this block with bolts through some oversized holes in this back plywood piece. That'll allow just a little bit more adjustment during final assembly, and that way I can make sure I get the sanding belt nice and square to the sanding table. The main structure is all complete and screwed together and screwed to the base. However, the motor has not been fixed yet, and I remember from before that I want the motor pushed all the way up against the back of this piece of plywood in here. And with that there, I can mark out the holes for where I want to put the motor. I got the motor mounted, but I still need to put on the pulley, which means I need to take all this off again. At this point, I'm realizing I should have done the motor mounting and the pulley a long time ago, but best laid plans. Okay, I got the drive pulley put back on, the motor's mounted, everything's screwed back together, and everything back in its place. I'm going to put on the sanding belt and get that tensioned up. And so I think the next thing will be to build a sanding table for the top here. For the sanding table, I'm using 3/4 inch melamine particle board. This is the same stuff I use to make my table saw top, and I've also used it on a couple of projects and workbenches. I really like it for a work surface. I wanted to round the corners on this tabletop, and the best tool for that is the disc sander. However, I couldn't fit the piece on the disc sander since my disc sander is kind of crammed in the corner, which meant I had to bring it out and put it on the table saw, which was kind of a pain, but it worked, and I actually enjoyed having all the extra space around while I was sanding. To finish off the tabletop, I use some iron-on edge banding just to go all the way around the edge, and it makes the tabletop look really nice. After I made that nice looking tabletop, I then cut a big hole in it because I needed this slot for where the sanding belt is going to slide in as I assemble the top onto the sander. First test for the strip sander. I just sanded an inside corner. Awesome. I cut this piece out to act as a filler for this spot. And I also drilled and countersunk the holes to attach the top. So I'll put some screws in and the top will be done. With the table done, the sander is almost complete, but I still need to make 2 more parts. I want to make 2 sanding platens that can slip in behind the sandpaper. One will be flat, and that'll be for sanding inside corners and just straight lines. And I want to be able to swap it out for a curved one, and this one will be for sanding inside curves. I haven't had a great idea on how to attach these easily so that they can be swapped in and out. So while I've been building it, I've been coming up with ideas, and I think I finally found a solution, but it's going to involve me taking this whole thing back out, so I'm going to have to disassemble this whole thing once again. I added 2 screws that will sit just below the table, and those 2 screws accept the slot that I just cut in the sanding platen, and so that'll lock the sanding platen in side to side, and when the belt is on here, that'll keep the sanding platen pushed up against the back, and that should keep it in place. To make the curved platen, first I'm going to mark out the radius that I want to carve into this piece, and since the smallest curve or radius that I can sand on the sander is about 2 inches, given the diameter of the whole sanding head, I'm going to mark out a 2-inch diameter arc onto this piece of hardwood, and then that'll give me a guideline for sanding down to the line. I put on a couple coats of paint and some finishing touches, including this switch, a place to hold the spare platen, and some rubber feet. I think by now you can probably see why it's better to have this aluminum bar than to have this block of wood for the support, as it just provides a little bit more space for some awkward sanding shapes. One feature that this sander is not very good at is inside really thin slots like on this platen or in between the teeth, as the platen and the aluminum support just take up too much space. However, if I really need to sand in between features like this, I can always go and use the back end of the belt. I made a 3D model of this sander in Fusion 360, and that's what I used to help me build this. If you would like to build your own, I will post the CAD model on my website that you can download. I'm looking forward to putting this sander to good use. I'll see you in the next project. This is a 1-inch strip sander or an oscillating spindle sander. Fuck. I'm going to put the drive belt on, or the sanding, it's the sanding belt. The only thing, no, not the only thing left to do. I wish.